Hello 20-2 students. So today we're looking at solving problems using quadratic equations. So this is kind of the summary of everything we've worked through in Chapter 6 and Chapter 7. We're putting everything together using all the methods we have for solving quadratic equations, and we're applying them to more complex types of questions that are usually word problems, often where you have to develop your own equation. So yeah, that's what we'll be working on today. So let's just jump right into the first example here. So it says, determine 3 consecutive odd integers if the square of the largest integer is 33 less than the sum of the squares of the 2 smaller integers. So our first step with any kind of a problem like this is to write the equation. So because we're dealing with odd integers, one of the ways that we can ensure that our variables are representing an odd integer is if we think about an even integer, we know that even integers are all divisible by 2. So like if we wanted to make sure that our integer was even, we could make it 2x, right? So x would represent whatever number you multiply by. As long as you multiply it by 2, it would be even. Now for an odd one, we know that it can't be divisible by 2. So if we change this even integer by either adding 1 or subtracting 1, then we'll have an odd integer. So for me personally, I chose to add 1, but subtracting 1 would work just as well. So now if I have this statement for one integer, let's just imagine that we put in, I don't know, say 3 was our value for x. So we'd have 2 times 3 would be 6, plus 1 would be 7. We're looking for 3 consecutive odd integers, and so make sure that you're familiar with this word because it does come up fairly often. Consecutive just means in a row, like one after the other. So what would be the next odd integer after 7? And I mean, you could go before 7 too if you wanted to, but let's go up in order. So let's say we wanted to do the next odd integer would be 9, right? So that would be, basically we have to have 2 added onto there. And so essentially what we could say is we have the first integer, 2x plus 1, plus 2 more. Right? And so if we simplify that, basically we have 2x plus 1 plus 2 equals 2x plus 3. So that could be our statement for 9. 2 times by x would still be the value. 2x times, or so 2 times 3 would be 6, plus 3 would give us 9. What's our next odd integer after 9? Would be 11. So in this case, it would be 2x plus 1 plus 2 plus 2. So 2x plus 5 in this case. Okay, so those could be our 3 statements for our integers, 2x plus 1, 2x plus 3, 2x plus 5. And of course, x could be any value. This doesn't have to represent 7, 9, and 11. It could represent 1, 3, and 5. Could represent, any set of odd integers. So we have expressions for our odd integers. So integer 1 is going to be 2x plus 1. Integer 2 is going to be 2x plus 3. And integer 3 is going to be 2x plus 5. Then we want to think about what they're asking us about the math that needs to be done with these integers. So it's saying if the square of the largest integer, so which one would be our largest integer? Well, it would be 11 or 2x plus 5, right? So the greatest addition there. So if the square of the largest integer, so let's just write that out. 2x plus 5 is our largest integer, and we're working with the square of it. So we would have to square that whole expression. So if this square is 33 less than the sum of the squares of the 2 smaller integers. Now, again, there's kind of 2 ways you could do this. So you could either say, okay, the square of this, you would have to add 33 to that to be equal to the sum, which means the addition of the squares of the 2 smaller integers. Okay, so let's just write that out. I'm going to start out by writing out this, and then we can worry about the 33. So the other component of this is that we have the sum of the squares of the two smaller ones. So that means we have our one smaller one is 2x plus 1. And it says the squares of them. And then we also have 2x plus 3. So here we have the squares of our smaller integers, and we're worried about the sum of them. So sum always means addition. So if I add these two numbers squared together, the square of this is going to be 33 less than what this is. So for me, I would just say, okay, less than I know means minus. So if I have these two squares being added together and I subtract off 33, that value altogether is going to be equal to the square of the largest number. Okay, so the trickiest part pretty clearly with these is interpreting the question in like algebraic form, right? So being able to write an equation for that. Personally, for me, I just find it's good to just be really, really methodical. Even now that I've written out this whole thing, I would read through it again against the question and make sure that it makes sense. So if the square of the largest integer, so here I have my square of the largest integer, is often I would interpret that as equals 33 less than the sum of the squares of the two smaller integers. So here I have the squares of the two smaller integers. I've added them together, and I know that that value minus 33 will be equal to this larger integer. Okay, so now I have my expression. You have several options that you can do. If you want, you can simplify it so that you can work with it a little bit easier. The other option you can do, if you remember, we talked about what do you do if you have kind of like an equation that has an equal sign in between two sides and both of the sides are quite complex. Well, the easiest way we learn to deal with that would be to go into your graphing calculator and enter one side as one graph and the other graph as the other side. So we would say bracket 2x plus 5 squared. And then the other side, it's going to be really complex, bracket 2x plus 1 squared plus, oops, no, not cosine, bracket 2x plus 3 squared minus 33. Okay, so now I go into my graph. Let's see, does anything show up? Yes. Does my second graph show up? Yep. Looks like it does, but I see that. Now remember, if you graph the two opposing sides of this, what you're looking for is the points of intersection. So I want to be able to see if I can clearly see that these graphs intersect at one point, which would be one solution, but I need to see if they intersect at another point up here. So I can see that they're both going off pretty high up, so I'm going to make my y maximum like way higher. Let's try 100 and see what I get. It looks like they're going to cross, but it looks like I'm going to have to make it even higher. Let's make this 200 and we'll make that, I don't know, 10. Okay, so we see that we have 2 points of intersection here. So now I would go second function trace, and I want to look for my intersect. So it says first curve. I'm going to move my cursor closer to this first point of intersection. Hit enter, second curve, enter, guess. So it says I have a point of intersection at -3, 1. Then I'm going to find my second one. So I'm going to go to my intersection and scroll way up, way closer to that point of intersection, and then second curve. And the next point I get is 4 and 169. So we need to keep in mind that for this to be true, our x values are the solution, right? So when we look at our solution, we're only concerned with the x components. So if we want to determine what our integers were, remember each one of our integers had an equation for it. It's not just the x value. So for integer number 1, we would have 2 times by, if we use the first one, 2 times by -3, and then plus 1. Oops, -3. So 2 times 3 is -6, plus 1 is -5. And then for our second integer, we would have 2 times by -3. Oops, I keep forgetting to put in the negative, plus 3. So -6 plus 3 gives us -3. And then 2x plus 5, 2 times by -3 plus 5 gives us, I forgot the negative every time. Okay, -1. Okay, so that means our one possible answer, for these 3 integers would be -5, -3, and -1. But we have a second possibility, which would be, we have 4 here. So if we plug it in for 2 times by 4 plus 1, 2 times 4 is 8 plus 1 is 9. 2 times 4 plus 3, 2 times 4 plus 3, so 8 plus 3 is 11. And 2 times 4 plus 5 is 13. So another possibility for our 3 integers would be 9, 11, and 13. Now, if you want, and what I would recommend when you're doing a test would be to say, to try it out, so to see if the math adds up. So we said the square of the largest integer. So let's try this one because it's nice and easy and low. So, our largest. Oh no, this is our largest because it's close. It's a higher number than -5, right? Closer to 0 or closer to being more positive. So -1 squared is equal to these two squared, so -5 squared plus -3 squared minus 33. So -1 squared gives us 1, 25 plus 9, so I'm just going to go in there. 25 plus 9 gives us 34 minus 33 gives us 1. And so we see that that is true, right? The square of our largest integer was equal to the square of our other two added together minus 33. So we can see that we can verify our solution so that if you're on a test, if you made a mistake, if this wasn't true in the end, you would know that you needed to go back and look at adjusting how you set up your equation, probably would be where the error would be. But since we end up with the correct answer, we know that we're good there. Now, alternatively, I should point out, if you guys wanted to, you could also have expanded all of these sets of terms and simplified, and then you could have factored it to solve for the values. So I actually have that. I can show you that right here. So basically, I would have just taken like the 2x plus 5, multiplied it out, 2x plus 1, multiplied it out, 2x plus 3, multiplied it out, minus 33. So, I get all of my values, and then, you end up with like a quadratic on this side and a quadratic on this side. But remember, your equation always has to be equal to 0. Here again, you have two options. You could have put this into each one of these into your y equals, especially if you're not comfortable like putting in all the brackets and everything like we did there. So you could have put these two in and you would have gotten the same result. Instead, also, you could have just moved everything to one side so the whole thing was equal to 0. So I did that by subtracting all of this stuff off of both sides. So I ended up with 4x squared minus 4x minus 48. And then I just factored that. So 4 was a common factor. I divided it out, which left me with x squared minus x minus 12. Two numbers that multiply to -3 and add to -1 would be -4 and +3. And so I get the same solution that I had here, right? -3 and +4 is exactly what I get by factoring it as well. So just so you guys are aware, there's many different ways you guys can solve these. You could have also applied the quadratic once you got to this point if you wanted. Or you could have just graphed this one graph and found the x-intercepts. So I just want you guys to be aware that there's not just one right way to solve these problems. The only exception to that would be if you were told on a test to solve it in a particular way or using a particular method, then you would have to follow that. Okay, so in this next one, we have synchronized divers perform matching dives from opposite sides of a platform that is 10 meters high. If two divers reach their maximum height 0.6 meters above the platform after 0.35 seconds, how long did it take them to reach the water? So we want to pull as much information as we can about this. So when we're thinking about maximum height, so again, if you just kind of visualize what this is looking like, we have, let's say, matching dives from opposite sides of a platform. And I mean, it's kind of hard to say, like, how is this set up? Opposite sides of a platform. Does that mean they're like standing at the same side but at opposite ends of the width? Or are they standing at opposite sides and there's two pools? I don't know. But either way, the general concept is going to be like, let's say if this is the end of the, actually, no, that wouldn't really make sense. Let's say if this is the end of the board, they're going to jump up from there. And then, the board is obviously above the water. So then they're going to reach their maximum height. And then down here, we would probably set this equal to 0. So that would be like your x-axis. That would be the height of the water, right? So when we think about what's happening here, they reached their maximum height 0.6 meters above the platform. The platform is 10 meters high. So this is at 10 meters. And if they reach their maximum height 0.6 meters above that, then the point of their vertex is going to be, and I didn't really set that up super well because actually I would probably say that the point where they jump off of would be my y-axis. So that way you'd be at 0 because the x-axis is time and the y-axis is height. So obviously you can't start at a negative time. So I would have set my y-axis at the point where they jump off of, so that my y-intercept would be 10 meters, and then here they're at 0 on the x because it's right on the y. Oh no, sorry, because that would be, sorry you guys, that would be the point where they left the board. So we don't know our x value, so we can leave that blank, but our y value would be 10.6, right? The 10 meter height of the board plus the 0.6 meters above the platform that they were able to do. Then it also says they reached their maximum height above the platform, after 0.35 seconds. So we do have an x value there. So 0.35 seconds. Then it's saying how long did it take them to reach the water. So basically the water is going to be here at 0 height. So we're looking for the x value at this intercept, right? So what do we know? Well, if we're given a vertex, always the thing that you go to should be the vertex form. So that was that y equals a x minus p plus q. Sorry, x minus p squared plus q. So remember that's our x value and our y value for our vertex. So we would have y equals a x minus, and then our p value was 0.35. So because that's a positive value, we keep it as x minus 0.35 squared plus our q value is 10.6. Okay, now if you remember when we use the vertex form, we have to solve for a using another known point on the graph. So the known point we use can be the point where they jumped off the platform. So that coordinate would have been at 10 on the y-axis and 0 on the x-axis. So that was our coordinate there. So let's sub those values in. So y was 10 equals a, x was 0 minus 0.35 squared plus 10.6. And then, let's see, so we want to get rid of this 10.6, so minus 10.6 minus 10.6, which is going to give us negative 0.6 is equal to, if we do negative 0.35 squared, we get 0.1225 times by a. So if we divide that decimal out, 0.1225, 0.1225, we end up with A being equal to negative 0.6 divided by 0.1225, which is negative 4.897. So that's our A value. So we get kind of like a longer decimal there. So now, again, you kind of have options. We can sub this back in and we can say, so for our A value, so we would sub it back into this original equation. So it's going to be y is equal to negative 4.897. I don't know, I'll round it off there for what I'm writing out. X minus 0.35 squared plus 10.6. So personally, what I would do at this point, this is going to get fairly tricky. You could multiply it out. You're probably going to end up with a value that you would need to enter into the quadratic because we have all those decimals and stuff like that. So you can multiply it all out if you want to do that, and make sure that you could do that if you needed to, like if you were being asked to do that in a written question. But I'm going to go in and put it into my graphing calculator. So negative 4.897 bracket x minus 0.35 squared plus 10.6. Now, I still have my window from the previous question, so I'm probably going to shrink that down quite a bit. My y max, let's see, their max height was at 10.6, so I'll maybe make my y max 12. And my y minimum, negative 5. Negative 2. Okay, that should be good. Yeah, perfect. So now we're just looking for how long does it take them to reach the water. So if we look at our parabola, they start on the board here and then they go from there. So we know that we can't use this x-intercept, partly because it's negative time and partly because that doesn't fit with our model of what's happening in real life. So we're going to go second function trace. We want to solve for our 0. Left bound, right bound, and we end up with 1.82. So we would say then in a written question you would just write out the divers hit the water after about 1.82 seconds. Okay. All right. Last example of the unit. So at noon, a sailboat leaves a harbor on Vancouver Island and travels due west at 12 kilometers an hour. So again, I kind of like to start drawing these out right as I'm working. So let's say this is our harbor and they head due west. So they're going to go this direction and they're going out at 12 kilometers an hour. 3 hours later, another sailboat leaves the same harbor and travels due south at 15 kilometers an hour. So in this case, they're going 15 kilometers per hour. I don't know why I drew that one so much longer. And then they're asking us, at what time to the nearest minute will the sailboats be 45 kilometers apart? So the distance between them for how far they're apart is going to be the diagonal there. Okay. So with a question like this, we want to think about what is our variable, right? So we're looking for what time to the nearest minute will the sailboats be 45 kilometers apart. So that means how much time they take to sail this would be would give us the distance, right? So however much time goes by multiplied by your speed is going to be the distance that you travel. So for this one up here, that would be they're traveling at 12 kilometers per hour. And another way that you can do this to figure out is you can use, like if we say 12 kilometers per hour, if we multiply that by the time, which is hours, if we think about how these units would multiply, if we think about them just as variables, kilometers times by hours divided by hours, the hours divide into each other and cancel out, and we're left with kilometers, which is our distance. Okay, so that means that we want to multiply our speed by our time, which is in hours, to figure out how far they are. And what you want to know is the distance in that direction and the distance in that direction that each boat is, so you can solve for the distance between them. So 12 is going to be multiplied by time, because the first boat sets out and it just travels for however much time. Now the next boat is not going to have the same variable t. It's going to have a different value because it leaves 3 hours later. So instead of 15 kilometers an hour times by the time, which represents how long this boat's been sailing for, it's going to have 15 times by the time, but minus those 3 hours because that guy got a 3-hour head start. So the actual expression for this distance is going to be 15 times t is 15t minus 15 times 3, which is 45. So that's the actual expression we're going to use for this side of the triangle. Now that we have our expression set up for the variables, all we need to do is figure out how can we solve for this distance between them. So if you look at what's happening here, we have a triangle, and because this one headed straight west and straight south, we know that this is a 90-degree angle here. So if you have a right triangle, how do you solve for the diagonal side? Well, we would use Pythagoras, right? We would use a squared plus b squared is equal to c squared. So we want to do the same thing here, but we want to fill in for our variables the terms that we have for each side. So side A was 12t, let's say, and we want to square that, plus b squared, so that was 15t minus 45, and that whole expression would be squared, is going to be equal to this side here, which we'll call our variable d squared. Oh, shoot, but we actually have a value there. We want to know when they'll be 45 kilometers apart. So we're not wondering what the distance is. We want these two to be equal to 45. Sorry about that, guys. So 45 squared. Okay. Now we can see, again, up to you, you could, well, no, you couldn't actually put this in, well, actually, yeah, technically you could put it in as two separate graphs, but that's starting to get a little bit weird. So let's work to simplify this a little bit. So 12t squared, 12 squared is 144, and t squared is t squared. Then if we multiply this out, we're going to have plus 15t minus 45 times by 15t minus 45 is equal to 45 squared, which is 2025. Then let's multiply that out. So plus, I'm going to put this all in brackets. So 15t times 15t gives me 225t squared. 15t times negative 45 gives me negative 675t. And then I have the same thing here, so minus 675t again. And then negative 45 times negative 45 gives me positive 2025. And that whole thing is equal to 2025. So now I just want to combine my like terms. 144t squared plus 225t squared gives me 369t squared minus 1350t, because negative 675 minus 675, plus 2025. Now, if I really want to, I can start, because I know in order to solve this, I always need this whole thing to be equal to 0. So I'm going to kind of skip a step and say I have plus 2025, but in order to make this side equal to 0, I'm going to have to minus 2025 from both sides, minus 2025. So actually this cancels out, and I'm left with this minus that is equal to 0, because these two both cancel out, and this one adds up to 0. Okay, so now I have my expression, and again, two options. So you could either put that into your calculator and look for your zeros, look for your x-intercepts, or we could throw it into the quadratic equation. So let's try that just to do something a little bit different. So remember, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So if we plug that in, negative b, which is negative 1350, so it's just 1350, plus or minus the square root of b squared, so 1350 squared, minus 4 times by a, which is 369, times by c. Now there's no c value there, so that means that, just like we saw up here, those are going to add to 0, so our c value is 0, divided by 2 times by a, which was 369. So what we end up with here is the square of 1350 minus 4 times 369 times 0 is just 0. So we basically end up with the square root of 1350 squared, which is just 1350, right? So we end up with 1350 plus or minus 1350 divided by 2 times by 369, which is 738. So if we do 1350 minus 1350 divided by 738, we get 0 divided by 738, which is just 0. And we know that the boats aren't 45 kilometers apart at 0 hours. So the only other option would be 1350 plus 1350, which gives us 2700 divided by 738. And that gives us 3.658, something like that, hours. Okay, now be careful. The question asked us at what time to the nearest minute will the sailboats be will be 45 kilometers apart. So we have a couple of things we need to account for here. We have 3 hours accounted for. So remember, this boat left 3 hours after the first one. So we know they have to be at least 3 hours. It has to be 3 hours after the departure. Sorry, let's revisit this question a second. So the first sailboat leaves at noon, and they're asking at what time. So not how many hours later or how many minutes later, they're asking what time. So the first one leaves at noon. The second boat leaves 3 hours later, so that would be at 3 p.m. And then we have this 0.658 hours. So what I would do is I would just figure out how many minutes that is. So I would do 0.658 hours. And I want to figure out how many minutes that is. So I need to multiply that by 60 minutes per hour. And if you're ever unsure of how to multiply, always remember that if you have a fraction as a unit, you have to set it up so that the units you don't want cancel out. So we didn't want hours, we wanted minutes. So if this is multiplied by that and divided by that, the two that are divided will cancel out if they're the same, right? So we're left with minutes. So I know I've set this up properly. So now I just do 0.658 times by 60, which gives me 39.5 something minutes. So when I'm asked what time it would be, the first one left at noon, and the total time that passed by until they were 45 minutes apart was 3 hours and 0.658 hours, which is 39.5 minutes. So we should say that their time is going to be 3 o'clock plus 39.5 minutes. So let's just round that to 40. So 3:40, the boats would be 45 kilometers apart at 3:40 p.m. is what you would write there if you were writing it out nicely as a written question. Okay, so just make sure you would write that in a full sentence. Okay, so that's everything for quadratics. Yay! So you guys have an assignment to do on page 430 that looks at some of these word problems where you have to develop your own equations. So go ahead and give that a try. And then, as you know, this unit was set up a little bit strangely in the on the web page, where I just kind of combined the units. So at this point, you should be able to go in and do Chapter 6 and Chapter 7 tests, okay? If you want to do, like before you do the Chapter 6 test, I would recommend maybe just reviewing the sections of Chapter 6 because that test will be focused on those. But I just didn't like the order that the textbook had them set up in, so that's why I kind of mixed them around a little bit. But if you review the Chapter 6 lessons first and then review the Chapter 7 when you do the Chapter 7 test, you should be prepared for each test appropriately. All right, so good luck on the tests, and I'll see you in the next chapter.